Right, welcome everybody. We are going to get cracking. So let's do a few introductions and explain a little bit about what's going on here. The topic today is an introduction to 19085. We will be using the chat feature. So if you can find the chat feature in Zoom, that's really useful. We have a question and answer facility there as well. We're monitoring both. We have a question for you later to give you the opportunity to win fabulous, well, cheap tat really. It's cheap pens and flash things.
They look pretty good to me, Malcolm.
You can buy it at your $2 shop.
Spared no expense.
So that's the sort of people we are. So we're going to get cracking in a minute. I do have to be quiet for 5 seconds so that our fabulous marketing guru can edit a video together and get it on YouTube at some point. So 5 seconds from now, we're off. Okay, let's get cracking. What could possibly go wrong with technology? Frank and I here desperately trying to work all of this magical stuff. So Frank, tell us about yourself.
Oh, well, good morning, Malcolm, on this great grey and rainy Melbourne morning. And if you don't like the weather, wait 5 minutes, right? Yes, so yeah, I've been on the committee since 1999 and chair for 10 years. And in that time, we got another couple of editions of it. And then happily handed the baton to you to get out the next edition.
I went out for a coffee and came back to find myself the chair.
Well, you should have stepped backwards, but never mind. And yes, well, we did try to, as you see down to the ISO logo, have a grand unified standard combining 13849 from ISO and 62061 from IEC, and that went on for years and years, and then that fell over, which was a great shame, yes. I thought.
Yeah,
and anyway, so it did. And still on the working groups for the robotic standards, TC 299, and TC 44, which is 62061. Yeah, so that's probably enough about me.
So I get to bore you about me. As Frank said, he kind of dumped the chair position on me about a year ago. I represent Australia on a bunch of the working groups now for the TC 199 safety of machinery. A lot of these standards we are taking on as direct text adoption. So it is important that we in Australia get an input into those standards to make sure what we get is fit for purpose.
Indeed.
They're not always fit for purpose.
No,
we're going through
as we'll see today,
times.
probably.
Yes. And then for my sins, I created the LMSS course that is the US 5-day training course on machinery safety around the B11 standards. Now, we have a guest here. We have a special guest, Monique English from Standards Australia, and she's going to encourage you to get involved in standards development. Hi, Monique.
Hello, good morning, everybody, and I hope you can all hear me okay.
Yeah, that's fine.
So I am the engagement manager here at Standards Australia in the manufacturing and processing sectors. I work closely with Malcolm and Frank as part of the SF41 Safety of Machinery Committee, who are members of the TC39 SC10 Safety, which is part of the conversation today. So yes, I am here to encourage you to come and join us and participate. There are a couple of ways you can participate. So firstly, it's through proposals. So Malcolm did mention we're doing a lot of direct text adoption of the work, but also there is also need for modification sometimes. And all that is required for those to be adopted or modified is a proposal. And so I am your front door to the standards world, and all the proposals for that come through to our team. There's also a few other ways to join. So you could join the technical committee. We have the SF41 Safety of Machinery Committee, which looks after a lot of the big portfolio of the safety standards. And they're also participating members of the TC39 SC10 Safety. And that means that we can contribute to the shape of international standards. We can also join working groups where there's a specific group who are working on a certain section of a standard or a certain thematic aspect. You can also join, participate by public comment. So it's a really vital part of the process, which is public comment. So every standard goes for a 9-week public comment where you can actually review the standard and submit your comments. We've also just introduced a new red line functionality, which will make your life a whole lot easier to comment. If you need to have any questions or want to reach out on some further information, you can see our email address up the top there, sem@standards.org.au. And we really look forward to hearing from you. I hope I was quick enough, Malcolm.
Excellent. Thank you very much, Monique.
No
And
problem.
if you don't sign up, Monique's going to come round and give you a good kicking, I believe. Is that how it works? I can't remember.
No.
And we would actively encourage you to get involved in it. You get the standards you deserve. If you put time and effort in, you get good standards. You can't complain if you get standards that aren't quite fit for purpose. There are some interesting aspects that we're going to cover today that we have some concerns about, and we won't be frightened to share our concerns on those either. So let's have a look at the complete set of.
Well, first thing we
standards
should say, Malcolm, is that neither you or I are experts in woodworking machinery. In fact, have you used a saw in your?
No, I have all 10 fingers. So,
so have I. Yeah, so I've used a handheld power saw, and that's about it, pretty much. So we're not here as experts or to train you on this, but to really hopefully encourage the experts to help us sort through these standards. So back to this.
Yeah, so you can see that there are under this series. So we start off with part one, which is kind of an overview, setting out a lot of criteria that's relevant to all of these standards. But then these are the machine-specific ones in here. So things like our horizontal beam panel circular saw machines. Now, I don't even know what one of those looks like, but I'd be keen to get people involved who do and have an opinion over whether the standard that's been written at ISO level, and predominantly in Europe, I think, is fit for purpose in the Australian, New Zealand market. But we've got a bunch of standards on there. A lot of those combined machines, I'm guessing, brings a whole bunch together.
Yeah, and there's stuff that isn't there. For instance, there are wood pressing machines, which I don't see in this list, which combine shards of wood into beams and so on. But the point of these is that they give you specific ways on how to guard and control these machines, whereas part one gives you the general overview, how to do your risk assessment, how to apply the safety control system and guarding, but this is the specific stuff. So it's useful, very useful to have.
Yeah, absolutely. But today we are going to talk about part one, which is the common requirements across all of those. And we'll move on and look at the agenda, what we're looking at today.
Yes, so the scope really is the whole of life thing that you see everywhere in terms of risk assessment and risk reduction, through from its assembly right through to the scrapping of the machine. And in the middle of that is the operation and modification and so on. It talks there about being applicable to stationary and displaceable machines, and displaceable are machines which can be moved around, but when they're in use, they're fixed at the spot. They're not running while they're being moved, so something that may be on wheels.
No, and we've got to get the criteria right. If we're using a machine like that,
yeah,
we have to use it in a way that's safe, which means making it kind of
precisely. That's right. Yes, and obviously to be used with the other parts, which was the list that Malcolm showed a moment ago. But part one, this part we're talking about today, really covers all the common requirements. So and the last point there is it's not covering explosive atmospheres. There's no information really about that.
So if you are going to comply with this standard, you need to comply with all of those. I'm not going to go through them individually. There are a lot of standards there. I can see we've got a team from Standards Australia just having a look at the webinar today as panelists. They are rubbing their hands with glee at the prospect of you running out and buying all of those from the Standard Australia website. Now, some of these, as you get into the right-hand side towards the top, they're part of 4024.1, part one. But there are a lot of standards in there that aren't as well, covering things like acoustics. We have fluid and hydraulic power that are been adopted in Australia, as well as things like tools for woodworking, etc. at the top. So there's a lot of standards that you need to comply with if you are going to meet the requirements of the standard. One of the things that we have to do as a group as we look through that is make sure that what's in there is applicable for the Australian, New Zealand market, and make sure those ISO standards. We might have something different in the Australian market on acoustics. I have no idea, by the way, but we may have something different on acoustics or on tools for woodworking or electromagnetic compatibility. It's unlikely, but we need to make sure of that before we go ahead and adopt a standard.
We did forget to mention that there were woodworking machine standards in Australian standard, but they're very old and they need to be replaced. That's really been the impetus for doing this. And this series of standards has come out of ISO in recent years. So pretty up to date. Therefore, the idea of adopting them, and there are so many in Australia after all.
Yeah, it is a big area.
Yeah.
I always like to have a look at definitions. I always go to the scope when I'm looking at a new standard, and then I go to the definition. So we have a clear definition of what a woodworking machine is. And then, as I mentioned earlier, stationary machines, displaceable machines, it tells us exactly what those are. And if we look at displaceable there, so it's stationary during use, but it's got a device that allows it to move between locations, typically wheels, but it might be rail mounted, it might be other means too. But displaceable stationary machine, we will come to some of the requirements around those later. Other one on there that was really interesting was that kickback.
Yes,
I know Frank and I talked about that.
Yes. So, I mean, kickback is absolutely relating to projectiles from the machine. And there's a number of ways of feeding material into these machines, either in the same direction as the blade is turning or opposite direction to the way the blade is turning and so on. And how do you control kickback in the best possible way? That's really what the specific standards talk about. But that's a very important part in terms of a hazard.
Absolutely, yes. Operational stop is, I put that in there really because it's probably not an unusual term for you, but it's an unusual term in standards. So we talk about the different types of stop in terms of being controlled and uncontrolled, etc. Operational is really, we're doing that not possibly for safety reasons, but we're doing that as part of for process reasons rather than safety reasons. And we will look at the different types of stops in a little bit more detail. But first up, and one of the big advantages of these standards is the fact that it does give you a lot of information about the hazards. And this is one where this is a great place where you can go. All I've done is taken the headlines here. Frank and I've just taken the headlines and put these in, but it gives you more detail on what those specific hazards are there.
Yeah, and you can see here, of course, radiation hazard. Who would have thought, in a woodworking machine?
So how's that come about then?
Oh, you've got lasers putting barcodes on and printing, serial numbers and whatever else. So there's certainly radiation potential in these machines.
And that's one of those things I wouldn't have even thought of, which is why it's so important to use these standards, because it's giving you information you may miss when you're going through your risk assessment.
Think of machinery as only having mechanical hazards, but of course all that list there are all typical machine hazards, all of these things here. So, and the material itself, there may be, dust or emissions, gaseous emissions, which are hazardous. These are machine hazards. Of course, these are all listed in part 1201, which is ISO 12100. The list is very comprehensive there, but this refers to the specific hazards related to the woodworking machinery.
And as you go through the very specific machines that fall under this overall thing, they'll have even be more specific to that very machine.
Correct.
Now, probably the two most important slides to have a look at today are coming up now. And I'll let Frank explain that.
Well, this is the performance level selection chart. This is not a risk estimation, as everyone will know. It's a way of determining what is the design requirements of the safety control system. Now, why originally the ISO committee came up with splitting out S1, which is a reversible injury, typically scratches or bruises, into another selection about frequency of exposure and possibility of avoidance, is a mystery to me. That just simply means that you can use crappier and crappier components as you go up the list here to performance level A. But anyway, when you go to S2, it's very similar to the category selection chart. In fact, it's identical really at that level, the only difference being the S1 part. And each of these performance levels, as we all know, relates to a probability of dangerous failure per hour. And that really does force the practitioner to use quality components. Quality and mean time to dangerous failure aren't necessarily the same, but usually so.
Yeah.
So up here you might have the Dick Smith micro switch, and down here you've got the top quality. What would you say? No, we won't mention any brands.
No, don't talk about brands.
But anyway, down here you've got the very high mean time to dangerous failure components. Essentially
taking you into that performance level E area.
Giving a performance level E.
Now, the interesting thing for me in this standard, and it's true of a lot of the machine-specific standards, this is quite, what's the word I'm looking for? Prescriptive in terms of where your performance level is going to turn out.
This is one of the big problems in this series of standards, is that it does prescribe performance levels.
And C is the highest in all of these standards.
Which is bizarre.
The highest level.
But C performance level C is the highest. You shall.
Yeah.
This is something that has to be debated in the subcommittee that's looking at these, and this is where we want the experts to come in and help us as to what they think. But ultimately, in Australia, you must, according to law, perform a risk assessment and go so far as is reasonably practicable.
Yeah.
And the first two tests in reasonable practicability are severity and probability,
Yeah.
which is your risk estimation. So you've got to conform with that and put your control system in accordingly. So if you come up with PLE and the standard says PLC, well, you've got to go PLE.
Yeah.
Yeah. End of story. So that's something would have to reflect in the
Yeah.
standard.
And so, and I think, one of it does concern me that, having seen quite a bit of woodworking machinery out there in the field, I'm not sure how on some of those they would come out at performance level C when it is a continuous exposure. Severity of injury is
very high.
Very high.
Yeah, and the possible avoidance of these high velocity ejections,
yeah, next to nil.
Very impossible to avoid.
But what does performance level C even mean?
Well, let's have a look at this next one.
Because I think this is the thing that
this is
probably the bigger worry.
So of course you see over here performance level C. So am I on the right one?
Yeah, you're on the right one. I just need to make that into a laser pointer.
Oh, right. Okay.
And that's not working for me. So I'll have to.
Oh, there it is. Here. No, you got it. Yeah. You got it. Yeah. So this is the old category 1, which means you've got to have well-tried components and well-tried safety principles. In other words, high quality components, and they have a very the pointer's not moving very happily, is it? Can we use the mouse pointer again? Anyway, you see there that mean time to dangerous failure, the green is high. So that's a very low probability of dangerous failure per hour, the green. Yeah, you see how that pointer's not working properly, Malcolm?
Yeah,
technology. Oh, okay. But I wanted to go over here and point it to that. Oh, there you go. All right. So in C, you are obliged to use high quality, high mean time to dangerous failure components. However, the standards don't mention anything about architecture. So presumably that means you could have a category 1 control system for all of these machines.
Yeah.
Now, category 1 in the old style of category selection simply refers to low severity of injury.
Yep.
That would not be acceptable for most of these machines. Now, of course, C can come across to here as well, category 3, or even there. Category 3 for medium mean time to dangerous failure.
And that's my concern. So you say PLC, but it covers such a wide area.
It does.
And I think that's the concern we have as a committee over whether this is going to be suitable. If I was going to be cynical, am I allowed to be cynical? I think I'm allowed to be cynical.
I think you're allowed to be cynical.
I think there's
skeptical.
Skeptical. Yeah. I think there's been a fair input from machine builders into creating
I think
this
possibly, yes. Let's think that might be in the background.
Yeah.
But we'd have to look at this in some detail, and we'd really want the experts from the machine woodworking industry to assist us there.
Yeah, absolutely, yes. So, and incidentally, happy to take questions. If anyone does have any questions, please feel free to yell out and let us know. We're going to take you through a few requirements now. Now, we're not going into this in massive detail.
No,
this is really
experts.
This is really just saying this is what's in the standard. So when we get into our control devices and control stations, got to be positioned 600 millimeters to 800 millimeters above floor level. That makes it easy to operate.
It's an ergonomic thing.
Reset has to be outside of what they call here the danger zone.
The old classic reset. Yeah, and you've got to be able to see where everything is that you're going to be resetting.
Absolutely, yes. Before we can start, we need our safeguards in place, which is why reset isn't restart. Reset is essentially resetting the safety system to allow you to restart. And then we have the first one that you can see of many here. It's saying that if there's potential there for prevention of unexpected startup, and we're using our control system for that, PLC is where we need to be. And you've just seen on that previous slide, well, that could be anywhere, and that's the concern that we have.
Can I just point out this a little interesting image there of the the key to the control panel sitting on the e-stop, which a classical place to put a key, isn't it? And may actually prevent the operation of the e-stop. Well, we did that on purpose, didn't we, Mark?
I wish we did.
To show the image.
I wish we did. We were looking for stock images.
Yes, indeed.
Which is always fun doing that.
Yeah.
When we get into safe stopping and braking, so what we try to do here is apply the terminology to the 3 types of stop. You can have an uncontrolled stop, where it's an immediate stop. That's typically going to be
Taking
an
the power off
emergency stop.
contactors,
Yeah.
for instance,
Or type 1, a control stop. Again, that could be an e-stop.
allow the braking to occur and then stopping.
Yeah. And then finally, that operational stop is really a control stop with power left to the machine actuators. That's a process stop, I would call, as much as anything.
Some of these woodworking machines have clamps that clamp the woodwork. You don't want them to be released.
No, absolutely.
So that would
not.
be a control stop too, keep power on the clamp.
And then noticing up there, we have our different stops and the performance level required. All the different performance levels for our
Nothing higher than C.
Nothing higher than C in that. Final comment on there: if you've got a normal stop button and if you ever ask a salesperson who works in machinery safety, they'll tell you that's a black e-stop. Just beat them about the head for a couple of minutes and beat some sense into them. That is just a mushroom style stop button, and it's got to protrude, and it shouldn't have a shroud, which is why we've used that. And then we're going to have a look at mode selection. Mode selection is covered in multiple type C standards. It's covered in quite a lot of the B type standards as well that you'll see there. And the criteria here is pretty consistent across them. So your mode selection can't override emergency stop. Nothing should override emergency stop. Mode selectors should be lockable. Now we've got a key operated one there. It doesn't have to be key operated. I've seen ones using RFID tags. I've even seen using codes and that and passwords. Not so keen on those because those passwords tend to be on Post-it notes next to the.
And I know you've deliberately done another thing here again to pick up the issue of people leaving the key in the selector switch mode. I've very well selected that image there.
No, but to be fair, the mode selection there, that is showing the status. Because the key is in a certain position. You don't want to be initiating any machine movement by using mode selection, and then in 99% of cases, that changing mode is going to initiate a normal or operational stop. However, when changing mode goes from a mode with a lower safety measure to a higher safety measure, it is possible to do that.
Yes, indeed. Yes, so some of the controls, again, we see that it's prescribing the performance level for these things for, say, hold to run devices, e-stop, speed monitoring, interestingly, speed monitoring. Now, speed monitoring, it does talk about this being potentially handled by the standard PLC, but the speed limit would be handled by the safety control system to the level of category 1. Or maybe if you've got a diligent user, a category PLE, possibly category 3, not PLE, PLD, category 3. So nothing much more to say about that. Manual reset is there shown as PLC as well, and enabling devices PLC, which these things we both agree by and large never going to be high enough.
No. It is a concern around those. We did promise you we'd talk about stationary machines and displaceable machines. In stationary, you're fixing it to a stable structure, almost certainly the floor. We have a nice little displaceable machine image there. We've got some wonderful stock images for this.
Yeah, it's a good one.
Got to be stable during machining. You don't want it moving around. So, but then it comes with wheels to be used when transported. Annex C gives you the tests around how you do that, how you make sure things are stable. So the annexes are particularly useful in this.
Really for the machine builder in that sense, isn't it?
Yes, it is. Yeah. And then looking at our tool holder and tool design. So we need that positive connection between the spindle of the tool, or we have a positive connection between the front tool flange and the spindle. So this is all about making sure things are fixed in place. And again, more geared up to the machine builder than it is to the user, but still useful to know this because you need to know what you're buying, what you're getting. So you want to avoid any potential risk of breakup during use. Make sure you've got measures in place to prevent ejection, etc. And you're likely to be using fixed and movable guards.
Yes, I did a training course once, Mel, where a guy was using an angle grinder, but he put the wrong size wheel on the hole, so the hole in the wheel was too big, and it shattered. And he was wearing a welding mask at the time that penetrated the mask. So this issue here of spindle control and locking and so on is incredibly important.
Yeah, if we are using braking, so one of the interesting things that comes out of this is if you've got any rundown time that exceeds 10 seconds, you need to have an automatic brake, because the maximum rundown time you can have with any of this machinery is 10 seconds. So you need to be using braking if it's greater than 10
Well,
seconds.
it says if you can't get it down to 10 seconds, then you've got to have locking interlocks.
Yeah.
You can't get in there
Yeah, until it stops
it's
spinning.
stationary. Yeah.
So we may or may not have a quiz question around that for you. So you might want to make a note of the maximum rundown time.
Mhm.
So yeah, you may have to use time delay, etc., and guarding to get around that. And on the subject of guarding, Frank.
Yes, well, of course, we talk about fixed guards in this standard. Now, they talk about permanent and fixed guards in the same breath, Malcolm. Whereas we have a guarding hierarchy in law in Australia, which separates those two. A permanent guard is something which is fixed by welding or gluing, such like. And then the next guard down is the bolted guard, which, according to the standard, as this overlay on top of it, that must be fixed with fixings which require a tool that's available only to authorised persons for removal. So if the average operator has access to a shifter or an Allen key, then it would be fixed with some kind of security fixing.
Yeah.
And that's the principle we've been applying all along. So the standard really here doesn't follow the law properly. But then it does talk correctly about interlocked guards without guard locking. In that case, it's showing the tongue type switch. I would always prefer to see a radio frequency style or some other non-contact system. And then the next one is the interlock guard with guard locking on the right-hand side there. And that is what we were just talking about. So you can't get in until a safe condition has been achieved, such as standstill. It again prescribes PLC. So there you go. That's the things that have to be changed. Showing there, hold the run device on the left, where you have to hold the button in the middle position, and the machine would only run at low speed, or maybe an inch mode, or limited inch, that sort of thing. So it's not running at high speed, and you're in total control. If you can, that's if you need a hand-free. If you don't need a hand-free, then a two-hand control is obviously the better way to go, the one on the right. And there's a specific standard for that. I think it's 4024.2601. I think
your memory.
I think so.
Fine.
If you
but it
could be proven incorrect there.
It is definitely part of
it is. That's been out for quite a long time on the two-hand controls. Yeah.
And then we might think about using
well, yes, presence sensing systems, and of course we have a plethora of those devices now. And as you see, the light curtains or laser scanners up there, or pressure mats, or now even I think what we have is a radar. Yeah, and these are coming out now at quite a high level, are they not?
Yeah, they are. So we will see some interesting developments around radar with laser scanner, I think, in the near future. And
also ultrasound sensors coming out at a high level of safety integrity as well. But again, it's prescribing, isn't it? PLC.
Yeah, PLC is the highest for all of these.
The type 2 isn't as low as a type C. Yeah, so I don't know. That's where they've gone wrong in this standard.
It is interesting. As you can tell, we're quite sceptical about that PLC requirement. Where we want to guard tools, we're going to use combination fixed interlocking movable guards. Got to use guard locking if you've got rundown time more than 10 seconds. And then if no interlock movable guards required, if tool rundown time is less than 10 seconds, access is not particularly frequent, tool changes less than once a week, etc. With drives, similar principles apply to that as well. And then with shearing and crushing zones, we're going to use guards protective devices. Where we can't guard tools with guarding, as we've shown here, fixed and movable guards, then there's kind of a hierarchy to move down of automatically adjustable guards, manually adjustable guards, impeding or deterring devices, and then into light curtains, electrosensitive protective equipment, and then into things like pressure mats, PSPE.
One thing that people should never do, of course, is use the presence sensing system where there's a risk of ejection.
Well, yes,
because the light curtain might detect it before it hits you between the eyes. But it's not going to stop it. Whereas that's where the physical guard comes in, and that's where the guarding hierarchy in Australia is very sensible. It does prescribe, a physical guard.
Absolutely, yes. Impact hazard, well, you need to think about limiting the speed of machine parts, etc., to 25 meters per second if there's no other hazard present. And then with clamping devices, if we're clamping something in there, you might need a two-hand control for clamping stroke,
So you don't
two-stage
caught in the clamp.
so you're not getting caught in the clamp with it. Because that in itself, you're introducing something that essentially is making things safer by holding something, but you're introducing hazards at the same time.
Yes, and you don't want that clamp to release, when you have a sudden stop.
No, exactly right.
It's a type 2 stop.
So it does give you some of the requirements there around fixed guards to around the workpiece clamp and the gaps associated with that as well. The other thing we need to consider is measures against ejection, and this is an interesting one because it split things into Class A guards and Class B guards. As you get into the more specific standards, they will tell you whether you need either Class A or Class B. And in here, what we're seeing is it's telling you what material
specific
can be
strengths
specific strengths.
And we went away from this whole prescribing guard design a long time ago, because who knows how strong that guard has to be. Only that specific machine designer will know what the force of that ejection is going to be.
And I think with that, as you go through, it does give you a whole bunch of details in Annex D about the impact test and the different.
At least it has guidance, but I wouldn't say you would say, well, I've done that. It's capable of 180 newtons per square millimeter. It's good enough. May not be. Yeah, that's where the risk assessment really is all.
It's going to tell you everything. Yeah. Good news on that, though, it does give you a lot of information about the different projectiles and how you test the guards with that as well. This part was really, I think Frank just saying, well, these are the things you need to consider. And these are the headline things. It gives you more details.
And not to forget things like the emissions of chips and dust, as we mentioned earlier. Ergonomics is often overlooked, I must say, in machine design. They put things in awkward places, or some of the controls are identical, but they do very different things and maybe more hazardous things. So just pointing out, and also the energy we're trying to control is not just mechanical. Maybe it's electrical, pneumatic, hydraulic. There's a whole bunch of things that we're seeking to control, that we potentially have radiation, lasers, and static electricity, and it may be a significant issue. We may have sparks causing explosions. So there's maybe people have to dip further into explosion hazardous environments.
Isolation is always an interesting one, and I can't remember off the top of my head whether it goes into a great deal of detail. One of the things we lack in Australia is a standard around control of hazardous energy, and that's something we're looking to address as well at the moment on the committee. We are looking at a standard around lockout tagout around control of hazardous energy, and potentially using the safe control system if that's appropriate. So these are all things that we need to consider.
Indeed. Now, I'm pleased to see this in the standard, because this is overlooked in so many sites I visit, that isolators and so on are not marked, or they might have a bit of masking tape on them with a bit of biro, or they've got some code number. Nobody knows what it stops and so on. So it's emphasising here that you've got to mark things durably and clearly, and have the appropriate warning devices and so on, information for you. So, very good part of this standard.
And that is becoming a much better in the world of ISO from my experience of late as well. So we've talked about performance levels, and it shall be performance level C, but it's saying here performance level requirement is informative, which seems a bit crazy, because all of the other annexes
contradicts itself.
Well, quite.
So I think this is one part we'd have to review carefully with the experts who join our committee. I think they're going to be clamouring now, don't you?
Yes. Who would want to work with us?
Yes. So that's one thing that's going to have to be sort of changed there. But and tests for braking function being normative. Well, I think that's fair enough for the machine builder. That's a must.
And we probably should just highlight here, these standards are written for the machine builder. And that is a bit of frustration when you're a user. And I think when we go through the process of looking at these, I think that's something we need to consider. And when we actually do our adoption, whether there's anything we need to add.
It's important to know that the person who buys the machine is responsible for its safe design as well, not just the supplier, also the user. So you kind of become a de facto manufacturer, because you've got to get it right. And the manufacturer may not have done it. It's come from countries to the north of here, or maybe even from Europe, but the non-CE version,
with the non-CE version with the CE mark,
the non-check everything version.
Yes, quite.
Okay, so impact tests and so on. Again, I say that really that has to be a function of risk assessment, but at least there is some guidance there, so that's useful.
Yeah, the annexes are pretty good in
Yeah.
the standard, but like you say, there's no substitute for a proper risk assessment at the start of the process.
Correct.
So that brings us to the end of the standard bit. We have
Yeah.
what we will do is email this out to you. Hopefully, it will be of some use to you as a wonderful gift for attending today. We've taken the wiring colours, the push button colours, and the indicator light colours that are written in lots of words in 1204, which is IEC 60204-1, and turn that into a wall chart showing you the different colours that are recommended for the different facilities, different uses, etc.
Yeah, very good.
Had a lot of interest in that. I popped a link on LinkedIn, but we will send a copy of that out. Let us know if there's anything else you want to see. As much as standards are there, and we kind of take pride in writing good standards, ISO doesn't do well with color. They're all black and white, and if ever a standard needed to do something like this, it should be in this one. It should be like,
well done to Cat 4 for producing it. Well done.
I nicked the idea from somewhere else. So can't take credit.
Yeah.
So if anyone's got any questions, please pop them in the chat. Pop them in the chat, pop them in the Q&A. We're happy to take questions now.
We can answer them later too.
Or answer them later, entirely up to you. While you're thinking about that, we have a question for you. So when utilizing braking, the maximum rundown time must be what? A, 5 seconds, B, 10 seconds, C, 15 seconds, D, 20 seconds. Answers in the chat, please. If you just pop them in, you can pop them in the Q&As as well. If you just pop any answers in there to that question, we are giving away. We've got some little torches.
They're wonderful. Quality. Yeah, I think
we've got some Cat 4
very high lead time to dangerous failure. Those torches, haven't they, Robert?
So thank you if you're participating in this. We will pick a couple of winners out of this, maybe more, and we'll contact you via email and say, hey, where do you want that? You're
getting some correct answers there already.
Yeah.
Well done.
Everyone was paying attention.
They were.
Again, if you got any questions, please let us know. One final thing, I'm going to plug some training next week that we're doing on risk assessment. So we have an excellent question here. Someone wants to phone a friend. Haven't quite got that set up yet on our machinery safety hot seat quizzes, but we're working on it. We're working on getting the phone a friend function in. So if anyone wants to come along and have a look at risk assessment, we've got a 4-hour training session next week. It is super cheap. It's $60 for 4 hours. You will get entertained. You'll get a copy of the information. Which we try and make this as accessible to everyone as we can.
It's the crucial standard. ISO 12100 or 4024 but 1201 are identical. Crucial.
Yeah.
It's where the life begins and ends on machine safety.
Absolutely is. We also take you through a kind of very brief risk assessment example and show you how we've done some things and looked at it. We try to be accessible, so we don't just use pictures of machinery. If you really love pictures of machinery, we do have some in there, but we try and make this open to everyone. So it's about understanding what engineers have to do. If you're an engineer, we try and explain.
And you struck out all the family, Mel.
Yes.
I don't know, they should come.
Funnish for all the family. Anyway, it's next Wednesday. If you check our LinkedIn profile or look at the Cat 4 website, you'll get the details. It just remains to say thank you very much
for attending, folks, and please consider joining this committee to review 19805. Have I got the number correctly? ISO 19805 series woodworking machinery standards, because we would like to adopt them in Australia, but as you can hear from our discussion today, there will be some modifications.
Yeah, almost certainly. And quick question, someone's just asked a question there about the email. We will be sending an email out. I'll put details of the training in there for next week. We'll have a link to the YouTube video of this. Believe it or not, more people watch the YouTube video than attend the webinar.
That's interesting, isn't
people
it?
have things to do, I guess. So we will put a link into that. We'll send a copy of the content out in PDF format. And for those of you who have answered our question, you stand a chance of winning the fabulous Cat 4 TAT, as we call it. So thank you very much for your time, and we'll see you again soon.
Thank you and goodbye.